In today's lesson, we're going to be looking at time and how to perform time conversions. So time conversions in our system are a little bit tricky because we inherit aspects from three different systems, right? We have 60 seconds in a minute and 60 minutes in an hour due to things we inherited from the ancient Babylonians. And we have 24 hours thanks to the ancient Egyptians. To make things a bit more complicated, we have 365 days, which was brought in by the Roman calendar under the time of Julius Caesar. There's also potential discussion, or at least some discussion, around having metric time. And you can click on the video link if you want to learn more about that. Right, where you might have 10 hours in a day instead of 24 or 12. So, just some little facts about time. Hopefully you are familiar with all of these things, but they become important when we start to do our conversions. So, this will be a helpful graphic to refer to. It's in your textbook. Right. If we want to convert between days to hours to minutes to seconds, note that we are multiplying each step of the way. Right. If I have 1 day, I'm going to need more than 1 hour in that day. I'm going to need 24 hours per day, 60 minutes per hour, and so on and so on. If we're converting the other way, we are always dividing. We are multiplying to go to smaller and more specific units, and we are dividing to go to larger units. So if we add months onto this, right, if we want to go from days to months, we need to divide however many days are in that month, so that's a little bit more complicated. And to go from months to days, we need to multiply by however many days are in that month. And then if we go to years, right, we will have 12 months per year, so we divide by 12 to go from months to years, and we multiply by 12 to go from years to months. One other conversion we might need to do is to go from years to days, in which case we'll multiply by 365, unless it's a leap year, and from days to years, we will divide by 365. Okay? We also need to go a bit further than the second, particularly in aspects of science. When we are trying to be more specific and precise with our measurement, we may need to go into milliseconds, microseconds, and nanoseconds. So a helpful way to think about this is that we are just going by 1,000 each time. Right? When we go from seconds to milliseconds, we are going to need to multiply the number of seconds by 1,000. Right? That's what milli means. To go from milliseconds to microseconds, we multiply by 1,000 again. And to go from microseconds to nanoseconds, we multiply by 1,000 one more time. So if you need to convert seconds to, for example, microseconds, if you want to do this, we just multiply our number of seconds by 1,000 and by 1,000 again. Right? So if we had, let's say, 3 seconds is going to be multiplied by 1,000 is 3,000 milliseconds, and to go to microseconds, we could either multiply 3,000 by 1,000 to get 3 million, or we could directly multiply 3 by 1,000 by 1,000 again, right, which is 1,000,000 to arrive at this same answer. So if we're multiplying to go that way, you can probably guess that we're going to be dividing to go from nanoseconds up to seconds. And again, we're dividing by 1,000 each time. So if we want to go from nanoseconds directly to seconds, let's say I have 9 million nanoseconds. If I want to convert that to seconds, I'll do 9 million divided by 1,000, divided by 1,000, divided by 1,000 again. Right, so we'd go, well, nanoseconds in microseconds would be 9,000, right? Losing 1,000, a factor of 1,000 on our nanoseconds. To go from microseconds to milliseconds, we'll divide by 1,000 again. And then to get from milliseconds to seconds, we divide by 1,000 one more time to give us 0.009 seconds. Again, removing our decimal point 3 spaces to arrive at 0.009 seconds. Okay, so what you should do now is go onto the links that I've put on this video, or they'll be on Sector, and have a look at the work examples of how to do these problems. So you should pause this video, do that. And when you come back, have a go at these. So pause this video, watch those two, try these, and then resume this video. Okay, hopefully you've gotten these two answers on the bottom. If you have, go directly to the fluency problems that relate to this. Still do your foundation, standard, or advanced, depending on what level you're at. But we're going to work through these right now. If you got them right, feel free to skip ahead in this video. So if we need to convert days into hours, right, we have 11 days. And what are we doing? Well, to go from days to hours, we need to multiply by 24. So we multiply 11 by 24. So we can set this up as a multiplication. Right, 4 times 1 is 4. 4 times 1 again is 4. We add a 0 as we move to the next column. 2 times 1 is 2. 2 times 1 is 2. Add these up. 4, 6, and 2 to give us 264 hours. Make sure to put your units at the end. It is very important for these questions. In B, to go from months to years, what are we doing? So if you recall from the previous slide, that to go from months, so let's go from years to months. If we're going this way, we multiply by 12. I just have a think, should I have more months than years or more years than months? If 1 year has 12 months in it, then my number of months is always going to be more than my number of years. So I need to multiply. From months to years, then I need to divide by 12. So in this case, I'm going from months to years, so I need to divide. So we have 42 months, and we're going to divide by 12. Right, so 12 into 4, 0 times 12 into 42 goes 3 times with 36. Right, 3 12s are 36. And I'm going to add a decimal point here. Right, we had a remainder of 6 left over. 12 goes into 60 5 times. So we then have our answer 3.5 or 3.5, and our units are years. Right, so now if you haven't already, have a go at those fluency problems at the level that you are working at. In this next section, we're going to look at how to convert between 2 ways in which we communicate hours and time. We're going to use AM and PM, right, where we separate our day into before midday and after midday. And we're going to use 24-hour time, where we just take the day beginning at 0 and ending at 23:59, just before that the next day. So note here that for 24-hour time and AM, they both look very similar. The only difference for AM and 24-hour time is that our 24-hour time has a 0 before it, or I should say we are always having 4 digits, whereas in AM we don't have to. There is no symbol between the hours and minutes, and we don't use the AM or PM for 24-hour time. But note that once we go into PM, we start to have a bit of a difference here. So here are your rules on how to convert between the two. If you need to pause and just have a look, feel free. So now you should stop this video, have a look at the links on how to solve these problems, and then have a go at the Now You Try section. So pause this and watch those videos and try these questions. So if you got the Now You Try section correct, move on to these fluency problems again at your level. If not, let's go through how to solve these ones. So 11:30 p.m. we want to go into 24-hour time. So I am following these rules here. This is 10:30 p.m. So I'm following specifically this section here. So I'm going to start by writing 10:30 p.m. and we'll see what we need to do. I need to remove the colon in the middle. And then I add 12 to the time. So that should be adding 12 to the hour of the time. So instead of having 10, I'm now going to have plus 12 is 22, 30, and I drop the PM symbol. So this is now 10:30 p.m. in 24-hour time. For B, I'm moving from 1720 to, now this is going to be AM or PM. If it's above 12, we are in PM time. So let's follow these rules down here. Subtract 12 from the hours. So 17 is my hours, minus 12 gives me 5. So this is 5. I add the colon in between. This is 5:20, and it was above 12, so it is 5:20 p.m. So if you haven't already done so, you can now have a go at those fluency problems and come back to this video once you've done those. So this final section looking at time is looking at time zones. Right, so because our Earth rotates around, the sun is going to shine on different parts of the Earth at different periods. We're never going to have the entirety of the Earth covered in light, and we're not going to have the entirety of the Earth covered in darkness. But we also want to be able to refer to these hours of light and hours of darkness in a similar way. Right? Here in Australia, we want to call 6 or 7 a.m. the morning when the sun starts to shine, and we want to have that the same in Europe and in Asia and in America. In all these places, we have a desire to have this similar way in which we talk about time. So we want 6 a.m. to be when the sun starts shining across the world. So to do that, we have divided the world, the globe, up into 24 lines of longitude. So that's these ones going down here. As we move around the Earth, you can see that we are either going to be adding numbers, adding hours, or we are going to be subtracting hours. So we have this area, actually cuts through England somewhere here, right, where we have the prime meridian or the main line of longitude. So this is called GMT or UTC, Universal Time or Greenwich Mean Time. So Greenwich is this place in England where we take that as the zero or the universal, the standard time. Anything east of Greenwich is ahead, we are adding hours. Anything west of Greenwich, we are subtracting hours. And in Australia, here in WA, we are GMT plus 8. If we flip back over here in WA, you can see that we are plus 8. You'll also note that these aren't very clear lines. Right? They're not just entirely vertical all across the globe. We have some very squiggly and occasionally very strange lines being drawn. Right? We have this area, which has the same time zone as New Zealand, which is GMT plus 12. But this section down here, this part of the world, even though it's getting the same amount of light in at the same time of day, it is only GMT plus 11 and a half. And then we have some squiggly lines around here where it seems that the actual amount of sunlight doesn't seem to matter. So our time zones reflect not only countries' boundaries. For example, China has a unified time zone. All of China is +8, even though these areas of China, the very west of China, is going to get the sun much later in the day than the east of China, which will get it very early in the day. But it reflects a country's desire to sometimes maintain just a unity across the country. It also reflects trade and who they want to be trading with, right? If let's say if New Zealand is closer, right, we are staying in the same day as Australia. So New Zealand is heading into the day sooner, but Australia is following a few hours after. Anything slightly east of New Zealand is going to be in the following day. So it's going to be a full 24 hours behind once we complete that lap. All right, so over here, on the very east of the world, remember New Zealand is just over here, okay, on our globe. But Alaska is instead -11 instead of being +13, for example. All right, and that's because Alaska is going to be trading mostly with the Americas, whereas New Zealand is going to be trading more with Australia and Asia. All right, so our time zones reflect geography and economics as well. So how do we do the maths? Basically, anytime you are going east of a country, you are adding time. Anytime you are going west of a country, you are subtracting time. So pause this video and have a look at the worked example videos, and then have a go at these yourself. And in a moment, I will run through these. I'm a little hidden now, but I need to see those. These are your answers up here. If you got them right, jump right to the fluency problems. If you got them wrong, stick around and I'll run through how to do them. So when it is 1 p.m. Universal Time, find the time in these places. So I've highlighted those regions to make this a bit easier for me. So remember, our UTC is this area here. Japan is east of UTC, so we are adding. And in this way, we are adding these numbers. Anything this way to the west, we are subtracting those numbers. So Japan is 9, so it's ahead by 9 hours. So we are going to add 9 to 1 p.m. So for A1, we're going to do 1 p.m. plus 9 equals 10 p.m. Number 2, Sudan, over here in Africa. Sudan is +2. So we are going to do 1 p.m. plus 2 is equal to 3 p.m. Peru. Okay, so this is the number 5, but we are west of the meridian. We're west to the left, so we are subtracting 5. So I'm going to be careful about how I do the subtraction, okay? 1 p.m. subtract 5 hours. All right, to make this a bit easier, I'm going to convert 1 p.m. into the 24-hour time. Instead of 1 p.m., that is 1,300 hours. So 1,300, or 13, the 13th hour, subtract 5 gives me 8. So this is 8 a.m. in Peru. Finally, Victoria, over here in Australia, we are in the +10. So we are going to do 1 p.m. plus 10 is equal to 11 p.m. So that was A. Now let's do B. For B, we are starting with 10:30 p.m. in WA. Right, so instead of looking at whether or not a country is east or west of the meridian, we are now looking if it is east or west of our state over here. So let's get rid of these arrows at the top and let's instead do this, where that is going to be plus, and to the west of WA is going to be minus. So 10:30 p.m. To make this a bit easier, again, I'm going to convert this into 24-hour time, where this is 22:30. So Queensland, Right, let's have a look at how far ahead Queensland is. Well, WA is 8, plus 8. Queensland is plus 10. So we have a plus 2 difference compared to WA. Right, so Queensland is 2 hours ahead of us. So when it is 10:30 p.m., we're going to add 2 to that. So 22:30 plus 2 hours is going to be 24:30. So let's have a think about what that means, because our 24-hour time only is up to 24. 24:00 is midnight. So this is actually half an hour past midnight in the next day. Remember that Queensland is ahead of us. So if we're near the end of our day, Queensland has already passed into the next day, or the next calendar day. China. So we are plus 8. China is also plus 8. So the time is the same. There's no difference in our time zone, even though the very west of China is going to be having a very different experience of 10:30 p.m. They may still have light out. So China is still 10:30 p.m. Argentina, over here in South America, is this a plus or a minus 3? Let's have a look. We are west of our prime meridians. This is minus 3. So we have to do a quick check here. To go from plus 8 to minus 3, what's the difference? So plus 8, remember for difference, we subtract between two numbers. Subtract minus 3, right? Subtracting a minus is equal to adding the positive, so that is 11. So we are 11 hours ahead of Argentina. So I need to subtract 11. I subtract because Argentina is still west of us. This calculation is the difference, and we are west, so we are subtracting that difference. So 11:30 p.m., let's use our 24-hour time because this makes a bit more sense. It avoids having to wrap around the AM to PM. You can do it, but the addition subtraction is a bit simpler during 24-hour time. So 22:30, subtract 11 hours. Right, so we're subtracting 11 from the hours in our 24-hour time. So that leaves us with, so 22 minus 11 is 11. So we are 11:30 a.m. Finally, in Alaska, over here, we are -9. So what's the difference between plus 8 and -9? Let's reuse my working out down here. Plus 8 subtract -9, that's now going to be 8 plus 9, which gives me 17. We are 17 hours ahead of Alaska. So 22:30, subtract 17 hours. Note that I'm writing hours all the time down here, because 2230 subtract 17, if you just put that into your calculator, it's not going to give you the right answer. We need to think about this being 17 hours. So 22 minus 17 is 5. So we are now 5:30 a.m. in Alaska.